Good afternoon and welcome. My name is Madeline Holzer. I'm the Education Events Specialist at Zahn, and on behalf of Zahn Academy, would like to welcome you today to our program. Welcome to LMT Lab Day Online. Today we have Milos Markovic, CDT, Director of CAD/CAM at Aurora DTC. He will be presenting the digital workflows in the dental lab today. Just a few things to keep in mind, a little bit of housekeeping. At the end, we should have time for Q&A. We implore you to use the question and answer tab on your toolbar, and we will address those questions as time allows. Welcome, Milos.
Hello, thank you everyone for having me. So nice to see my fellow dental technicians finally joining us for LMT. It's been an interesting year, to put it that way, to put it nicely. To give you a little bit about little information about myself, I'm a certified dental technician. I originally come from Eastern Europe, came to the United States, studied restorative dentistry at New York City College of Technology. And since then, I worked at various companies, including Denmat, Nobel Biocare, some boutique Crown Bridge dental labs in New York area. And then I kind of switched focus over to the clinical side when I worked with surgeons and some prosthodontists in the area to kind of complete that experience. And I believe that's what a lot of us technicians are missing, because we always work so heavily and we work really hard on the lab side, where we kind of separated from that clinical world, that clinical side of how our restorations end up performing in the patient's mouth, what that appointment looks like. And, what being there really allows us to improve our design and our work to truly understand what doctors and patients are going through. So anyway, bringing all that experience together, today I work at Aurora DTC, formerly known as CMC, as Director of CAD/CAM and Implantology. I try to help labs across the country achieve success by doing some really complex problem solving, whether it's design, manufacturing, case planning, anything related to that. So today I had the opportunity to work with Zahn on this presentation, where I really wanted to show you some of what we do and some of the options available today in a dental lab space. There's been some really new exciting materials, some new exciting workflows. So try to put together sort of like a buffet of options that you have today in a dental lab space, so that you can kind of choose your own path and see how this can help you. So today's landscape. So we've had a lot of improvements lately with new releases, with different types of materials, 3D printed materials, new formulations, new composite-like materials, so many different new releases that over the last couple of years, they just keep coming out over and over again. And then we've had a lot of new library files, new implant components that are being released constantly every day. And then, of course, lots of software updates, lots of new things that companies just keep releasing all day long. So to put it lightly, that kind of stuff can, even those of us who follow it religiously, can drive us pretty crazy. So we can get pretty upset. So the point of today is to kind of clear up some of this mess, some of this noise that's out there in the market, and to kind of focus on and narrow down a few things that I thought were very interesting for lab owners to know today. So main developments, we've had some new materials in the zirconia space, as I like to call it, sort of like the third generation of zirconia that keeps coming out in the last couple of years. When we initially started, we had that zirconia that was really opacious. Then the next generation was kind of that multi-layer gradient zirconia. And now we have this third generation zirconia that I like to call that has all the strength, the 1200 megapascal strength, and then nearly 50% translucency. And those have kind of been like the interesting things that have been coming out. So transitions is one of those materials that here at Aurora, we use and have used since its inception. And we've gotten some really great results. So then we have a lot of implant components that are constantly being FDA cleared and approved. It can be complicated to kind of keep track of what's going on in that space, because, the FDA, kind of like all these implant companies constantly send newly released products to the FDA. So the FDA clearing them onto the market can be a slow process, but it is going on, it's moving. And so there've been some really new interesting developments there with desk components. And then, of course, what I've seen is a lot of cross training between younger technicians, new up and coming technicians like myself, and some of the industry veterans, guys who have done dentures and crown and bridge and implants from like the Brennemark days, the 20, 30 years ago. And so I've found the need to get a lot of cross training, a lot of experience and knowledge from these guys. And so they've also been training a lot of new up and coming technicians, because if we don't get trained, we won't be as good. We can have all the digital knowledge and all the tools and toys, but we have to know the fundamentals. So that I've been seen a lot of crown and bridge technicians getting cross trained in dentures, and denture guys learning the crown and bridge, and then kind of completing that circle to make us very efficient and powerful tools to restore cases today, because a lot is expected of a technician today. So I'd like to take you on a little trip where we're going to take different paths, right? We're going to take the zirconia path. We're going to take the implant path, the 3D resin path, a fiberglass composite path, and the PMMA path. For zirconia, we're going to be using zero-lux transitions. For desks, we're going to be using, for implants, we're going to be using the desk components. For 3D resin, we're going to go over some Lucitone 3D digital print stuff. For fiberglass composite, we'll have to measure some of the Trilor stuff. And the PMMA, we have the zero-lux temp. So the challenge, we get a big case, we need to restore it. This was a patient that was presented with full extraction, a lot of bone reduction. And these are some of the more complicated cases you're going to get in your lab. And so the restorative options are endless. You have to know what kind of materials you have at your disposal and what's the best way to restore this case. So we take it to the design, obviously, which can be a lengthy process, but we put a lot of effort into creating a nice prosthesis for maxillary and mandibular arch. However, believe it or not, that's actually the easiest part of the process. The hardest part is planning out what you're going to do, what material you're going to take, and which path the case is going to take, which is why I like to take you on all these paths. So we have here, I like to mention, after the case has been designed, we have to consider the strategy, math, CPUs, and GPUs. This can get a little technical for some of you who are maybe not as involved in a computer space, but some of you who are also would appreciate some of this. So everything we design is put on a milling strategy, right? So we have to run a milling strategy so that we can calculate it and make sure everything mills correctly, that all the screw channels and the interfaces mill correctly. So I've seen a lot of improvements in the hardware space where powerful processors and powerful video cards really help improve the process, speed up the process. So if I was to ever make a suggestion, would be not to underestimate the value of putting a lot of resources and investing in strong computer hardware. On the lower hand, you're going to see that I've shown an example of my computer where I actually loaded AMD processors in the last couple of computers that we built for computer workstation design. This has been the new development that even some people at 3Shape have actually not had enough time to test. AMD processors are now coming out, competing with Intel in a big way, because Intel has been the standard for a while. They offer a lot more processors, a lot more cores, so you can actually render some of these full large cases much quicker in your software. And they can also help the milling strategy calculate much faster as well. Then, today you have to think about in terms of ergonomics. You want to make sure that you have, a good setup, a good chair, ergonomic chair. A tool that you see here is from Razer that actually helps you put all your shortcuts on your computer, so you work very efficiently, so that you're ergonomically placing your hands. And also, you want to make sure you use blue light filter glasses. So these are all the new tools. Think of it as investing in a set of porcelain brushes or really good hand pieces back in the day. I've seen that we sit a lot at our computers now. Whether you're a crown and bridge technician or denture technician, you end up being a designer. We really only have a designing department and a manufacturing department at this point. So investing in that such hardware would be very beneficial. And I think changing our way of thinking would be would strongly improve that process. So after we go and crunch those numbers, as you can see, you had a chance to see here, we want to make sure you put the sintering stabilizer on your full arch restoration so that there's no warping during your sintering process. And then you can also sort of accentuate some of the areas that you want to mill in high detail and make sure you put the proper sprues. Here, as you can see, we use a C-clamp, which actually allows 90-degree milling so that those interproximal areas get milled out at a really high detail. Then we go ahead and obviously have a case that's been milled. We take it out, we analyze it, and after we cut it out, here you can see an example of green state finishing. As I'm sure many of you know, green state finishing is really the way to go. We've cut down really sintered zirconia finishing in totality here at Aurora, because we can see that our ceramics can really put a lot of their detail and contouring and individualization in their materials in green state. And all the research so far has shown us that once you sinter zirconia and start grinding on it, you're really reducing its properties, you're diminishing its properties. So if your zirconia is rated at 1200 megapascal, you're bringing it down. Each time you grind on it and you see those sparks flying off of your green disc, you're going 1200, 1100, 1900, 700. You just keep killing that zirconia's strength. So really the way to go is to do it in green state. And here you can see we also keep the sintering stabilizer on, obviously, which acts as a stabilizer for warping, but also acts as a handy tool for the ceramist or whoever's working on it to hold it while they're contouring it. So the benefits overall. After that, the case is sintered. Now, Zerlux Transitions is unique in that sense that it doesn't have a speed sintering cycle. So you really have to let it sinter fully. And so, sintering is important for you to not just take, if you get a new zirconia, you don't want to just stick it in your oven and sinter it as, the previous zirconia that you used. Every zirconia is slightly different. And those small differences in temperature can affect the pigmentation in the pre-shaded discs. And that's another thing. All these new discs that are coming out onto the market, they're all pre-shaded. The benefit of that is tremendous. It streamlines the workflow. We don't have to spend a lot of time pre-staining them. And the shades are just getting better and better. And if you can see here, even at this stage, when it's just been sintered, we're already starting to see some of that translucency that exists in the material. So it's already starting to look promising. Here, I wanted to just take you on a little 1-minute break where you can see how some of our ceramists here at Aurora spend their time layering the pink porcelain. We still do that, and we find it very beneficial to the overall aesthetics. One of our ceramists, Ellie Trainer. It's nice enough to share this.
Now that I have you standing here, I must confess my sin. Right there in front of you, I've been right there, waiting on you to see the sign and recognize what the rest of your life looks like. Ever since the day, looks like. Ever since the day, ever since the day, ever since the day, ever since the day. I must confess, looks like. Ever since the day, ever since the day, looks like. Ever since the day, ever since the day, ever since the day, ever since the day. I must confess, looks like.
That was great, right? So we want to thank Kelly for providing that for us. And as you could tell, if we go back to the previous slide when we were talking about the milling strategy, a lot of the detail that you saw in the material really comes from calculating that strategy correctly and really getting those milling burrs to minimize your finishing and contouring time in green state. You know, there's so many different options for the nesting softwares and the CAM softwares out there. There's some that are a little more complicated, a little more open source, a little more complex, and there's some that are like very streamlined. For example, if you take a Mailbox, some 3D, some of those pieces of software are they look simple because they're very simplified interface, but actually in the background, a lot of the math, a lot of the calculation is happening because they have it streamlined for a lot of things today, like angular screw channel and milling out the details and really recognizing the software having the ability to recognize all these different restorations that you're throwing in: bar, abutment, screw retain, regular crown with a screw channel, a bridge. It's like it's gotten really, really good, and it's made our lives easier. So here we can see some of the final products. So everything that Kelly did, we took some pictures, and I wanted to show you how Zerlux transitions really comes to life. A lot of our customers at Aurora before are used to using standard Zerlux zirconia. So once we started really offering this to our customers, everybody's asking for this right now. It's really great. It's 1200 megapascal, 48% translucency, and the material really, really comes to life. My wife, who's at home with kids right now, who's a CDT, she's a certified ceramist. She also appreciates a lot of this. You know, she remembering back in the day of how much staining and glazing and contouring had to be involved in producing lifelike restorations out of zirconia. So how far the material has actually come, it's amazing. So as you can see here, we have some really good translucency, really good light reflection. That pink really comes to life with the material. Over here, I took a couple of shots when I really wanted to show you how the light shines through the material there on the left-hand side. And then here, kind of like an angled shot where you can see how the pink, the purple, the pinkish halo that kind of always exists around the pink layered restorations kind of shines through right at the gingiva and the transition between the two transition, no pun intended. So here, I wanted to show you how the restoration comes together once it's finished with DES implant components in there. We're gonna move over to the implant path afterwards, but I'm gonna mention it a little bit, but doing it through the software, you just get this seamless integration of really great material on the zirconia side and the strong implant components on the other side that are gold hued, and they really come together great. And we really had no issues. For the cementation protocol, we used multi-link hybrid abutment cement and monobond pre-treatment liquid on both the titanium base and the zirconia, so that zirconia gets sandblasted very lightly at a very low PSI on the inside of the interface. The tie base from DES actually comes pre-sandblasted, so we don't touch that. We just apply monobond, and then we can take the multi-link hybrid abutment, put them together in a nice, clean, steamed off surface, and you're good to go. The restoration really lasted. It looks great. So here, the mandibular arch, we actually split in two. I had Kelly stain and glaze and layer only one half of the arch. So here on the left-hand side, you can see the center stage for the material. And then on the right-hand side, you can really see how the material comes to life once you stain and glaze it and layer it. I keep mentioning the layered pink because I know there are a lot of options out there for just painting on the pink for the gingival side, but over and over again, we keep getting requests for layering because the feedback that we keep getting is it's more aesthetic. It just pops. It just comes to life. So that's the benefit of layering pink gingival porcelain. And as you can see, material, the zirconia itself also comes to life. So I thought those were very interesting to show, to kind of show the contrast between the two. And then each one of these paths that we take, I like to kind of give you pros and cons for each material. This is where, going back to where I mentioned in the beginning, if you choose a path and you choose this material, you got to know what you're dealing with. You got to know, what are my pros and cons? So for transitions, it's the king of strength, 1200 megapascal. It's very aesthetic. We have that 48% translucency. It's appreciated workflow. So it makes your workflow much more simplified. You don't have to have so many different types of gradient discs and opacious discs and this disc, and then you have to spend time pre-staining it. No, you buy one set. It's for every indication, single units all the way up to full arches, and it's pretty color accurate. here, if you can see on the shot, you can really see that incisal profile shining through, or being able to see through it. And then as a downside, and this is true for really for any zirconia, it's heavy, right? This particular zirconia, fully finished, it was around 71 grams. And I'll give you that in relation to some of the other materials we're going to mention along the presentation. And you cannot speed center it. There are materials out there that you can, but transitions really works well if you center it at a normal centering cycle. So, but we really found that not to be a problem at all here, because most people can wait a day to get their zirconia done right, especially if it's a full arch, and especially if the patient is spending so much money. So here, let's take over the implant path. So I wanted to help you decide which parts to work with. It's like a little pun I put together. Now, Des has been a company I worked with for about 10 years. It has changed the way I do implant dentistry, especially because I worked with some of the OEM implant companies myself. And I know how things are done over there. And I know what challenges are when you're a lab owner and you're trying to restore a case. So the benefit of using Des is it's a one-stop shop with a wide range of supported implant systems. So they support all the major brands and then all the platforms within each brand. The benefit of doing that, of having that ability to work within one system, is if you receive a patient, especially now these days with a lot of older patients are coming out with failed restorative, and they're trying to get their new restorations because the restorative has failed, but the implant is good. They're coming back with external hexes and Brandemarks and all these older types of implants. You can actually restore them much more efficiently with Des, especially if you have a Straumann next to Nobel, next to Astra, and so on and so forth, because over time they might have gotten different implants placed in their jaw. So if you go with each one of these OEMs, it's kind of hard, and you have very limited options to restore this case in a more uniform way. Whereas Des allowed me to just have total flexibility and to go ahead and just start restoring these cases within one ecosystem. So it has helped us a lot in that way. And then ability to create screw retain restorations with angulated screw channel. So we don't do custom abutments as much as we did back in the day. I've seen it on my side, and I talked to others who told me the same thing. The screw retain, the challenge of a screw retain restoration before was wherever the screw channel goes, that you kind of set in stone, right? But with angulated screw channel, which is in Des's case, 25 degrees in any direction, buccal, lingual, mesiodistal, doesn't matter. You're actually streamlining your production. That you only have to worry about the tie base and the crown that goes on top of it. And you're actually introducing less components that could fail over time. Think about it. If you were doing a zirconia abutment with a crown on top, you have to get a tie base, cement an abutment onto tie base, and then cement the crown over that abutment. So you're doing two cementations with a lot of potential moving parts and a lot of potential for failure. So doing screw retain restorations has been more of a trend that we're seeing. And so having the ability to move that 25 degrees, that screw channel, especially if it's going through the facial, or you want to make it more clinically friendly for the dentist, that's been a big challenge, and that's what Des allowed me to do for the last 10 years. And then you can mix and match scan bodies. This is really good because sometimes you run out of scan bodies that are desktop scan body or intraoral scan body, or the dentist scanned the same case, for example, for Nobel with an Elo scan body and a Des scan body and Atlantis scan body, whatever he had on the counter, he just rolled it over, put it in a patient's mouth and scanned it, right? So a lot of systems don't let you do that. So Des's digital library, it really allows you to do that, which I'm going to show you in a few moments. And we have an easy nomenclature to order parts. So it's important what manufacturers call their stuff when you design them in 3Shape. So if somebody wants to call their tie base conical connection RP, that's great, but which part do I order? I can't just call and I need a conical connection RP. Conical connection RP what? You need a tie base, engaging, non-engaging, this and that, and so on and so forth. So Des simplifies the ordering process by incorporating the name tag within the design software, so that when you're done with your design, you can kind of get a summary at the end, where you can just jot down those parts, give it to your ordering department, or you order it yourself, and you just go to Zahn's website and order what you need to do, and you're done. So the point of using them really for me was to clean up the clutter. I like this picture. It's not my personal picture. I found it online. It was pretty easy to find. There's a lot of clutter out there, but the point of this is to clean all that up and make a nice streamlined protocol. And so here, I want to give you an example of, for those of you digital gurus, of what kind of options you have. So when you load your 3Shape software, for example, you're going to see that everything's labeled very clearly. Nobel Active. And then here, let's say for Nobel Active, we have the RPs, MPs, WBs. And then within each of those categories, you have engaging, non-engaging. And then at the end, you get that 5-digit number that really simplifies your process. And there's no confusion to what you need to order and then what the person cementing the case needs to use, because they can mix up those parts if they're not paying attention. Here you can see for angle base, which is their angulated screw channel, you have the 37042, which is active RP, which is what we used on this case. And you have two options, right? So you have the desk tie base, which is the straight, and you have desk angle base, which is the angle to 25 degree. And those are really the two options. And within each of those categories, you have all the implant manufacturers' sizes, engaging and non-engaging components. So the categorization is pretty simplified. Here about mix and matching scan bodies. Once you load their library, you're going to see first they start off with their own proprietary scan body, which is the intraoral. Then you can support their desktop scan body. Then if we go down, they support official 3Shape scan bodies for any one of these systems from OEMs. Then they have a little plastic thing you can 3D print to put on top of their tie base. Then you have Elo scan body, that the case was scanned with that. Then you jump to Atlantis scan body, and it just keeps going. And then you can even go with OEM, like this is the Straumann scan body that you can use for bone level. And then as you mix and match, all these components get converted to, all this information gets converted to desk components. And so it's very easy to work with. And then what I mainly saw my work grow and the way I was interacting with dentists really came to fruition where I started doing these, I call them clinically friendly screw channels. A lot of times the dentist would say, oh, but this implant's all the way in the back. I don't know what to do. I can't get a screwdriver in there. Maybe we should just do a custom abutment and be done with it. It's like, no, wait. Let's not do custom abutments anymore. I don't want you to load that thing with a ton of cement and then the implant fails because you can't clean it up well. So this allows us to do clinically friendly screw channel. What that means is you're moving the screw channel towards the midline so that, or wherever you want, but in this case, it will be towards the midline where the clinician can actually have easy access to go in, screw that restoration in and out. The retrievability and the serviceability of screw retain restorations is the main selling point. It's the main reason why we do it. We don't want to cut a crown off of a custom abutment. We want to be able to service it. We want to screw it in and out, service it, manage it, clean it, fix it, and then put it back in. We want to be able to easily analyze how the tissue behaves with it. And so having the ability to put those channels accessible to the clinician, it really help you as a lab as well to be like, hey, doc, I'm giving you all these fancy screw channels. How about let's do some more work? And it's really worked out. I'm kidding, but it's really beneficial. So, to just put it in like a simple animation, you want to make sure you move them under that 25-degree angle. This is their angled screwdriver. It's the same for all the platforms. So you just need to buy one or buy one for your dentist, and you can do all angled cases with the same driver. They come in 3 or 2 different sizes. I'm not quite sure, but I know there's a 25 millimeter and a 35. And then here, as you can see that, screwdriver trying to get in, it's really hard to screw in a big restoration at a 90-degree angle, especially when the patient has limited ability to open their mouth. Here, I call it reach the right cuff height for happy tissue management. So during your design, if let's say you're unhappy with how subgingival the implant placement is, and you really don't want to have those really long and thin zirconia necks that, first of all, are extremely difficult to place because the tissue shrinks right away as soon as you take the healing cap out. And then you're actually weakening the zirconia because you have these really long and narrow zirconia necks that you usually have to keep at around 0.5 millimeter thickness. So you might want to opt for a tight titanium base that matches that cuff height. So that's another layer in ordering and designing these cases. You can choose within the same platform the right cuff height. So you really have all of your zirconia sit at tissue level for happy tissue days. And that's it. Now, throughout this, I'm going to show you how DES components integrate into all these paths that we're taking. But it's really the company that you got to work with to really understand how simplified it can make your process and your workflows. And their components are FDA cleared. So that's another thing that's becoming more and more important. So when I go to the dentist and say, hey, doc, FDA is knocking on everyone's doors. I really want to make sure I use high quality components for your patient. This is it. And they go for it. They're usually skeptical, especially if they use a particular system. But then once they try out the angulated screw channel, it just makes their lives way, way easier. And they look really good. And it makes your life easier as well. The PMMA path, right? So I call it the path of verification. There's a lot of uses for PMMA, and it's great. We use it for a lot of things. It's a great material, looks great. But what I really like to use PMMA for is for verification. I don't jump straight to, zirconia. I don't jump straight to, finishing the case without enough data. I want to have as much data as I possibly can. So I use PMMA as that tool. So in this case, for this patient, we had, I said, many different markers that we try to verify with the PMMA restoration. And I find it's a very inexpensive way before final restoration. So we verify phonetics, aesthetics, we verify occlusal plane, interpupillary line, the midline, everything that you need to make sure that that case is done right. And then the tissue color, because you can actually get Gradia composite, for example, in different shades. So sometimes what we do is we put a different gum shade on the mandibular arch if it's upper lower, and a different gum shade on the maxillary, so that while the patient is not only verifying all these things I just mentioned, they're also saying, hey, I actually like this tissue color better than this one. So now we know what to go with. So it's a great tool for verification, and I like to use it in that way. And then here, as you can see, try to verify all those markers, all those landmarks that we really need before we take it to the final restoration. After those changes are made, then we go ahead and we can either scan in the restoration or slightly tweak it in the software, or just scan it in and just copy mail it. So there's different ways how we can transfer that data over. But pictures and PMMA, right on. It's like the best way to save yourself time and money, and the dentist as well, and a headache of going straight to zirconia and trying to work your way backwards. And then we have the Lucitone path, the solid base. So Lucitone, digital print. Here at Aurora, we have our printers where we print Lucitone, dentures, and we've done quite a few so far. We've been part of a certification process as well. And then here, I just want to show you quickly how traditional digital denture is done on the finishing side after it's been designed. So we have a mandibular and a maxillary arch set up. Those bars that you see across, they're placed to prevent any warping during the 3D printing process. All dentures are printed at about 70 degrees. And so those bars prevent from any warping during the printing, and they really help. Those are done post design. And they're all made for Dentsply's IPN 3D teeth. So those are placed individually. So we take those teeth, we glue them in individually, and then we put it in a special curing unit where they all kind of come together and solidify. And then after that, after everything's solidified, we start cutting things off, starting to smooth the surfaces. And then we go ahead and finish the Lucitone dentures. And as my friend Oscar Galvez, who I'm hoping is watching this, would say, he's been getting amazing fit on digital dentures when we spoke once. And that's been true. That's been the feedback that I've been getting, that they really fit great. A lot of people are skeptical with digital dentures because, what processes do I need? What steps do I need to take? I'm not really sure. In reality, the steps of gathering the data haven't really changed much. That's mostly the same. It's more on the manufacturing side that you're really saving time and you're getting a much more solid product with dentures. It's very labor intensive finishing dentures. And so here we have an example of some of those finished dentures. Now, what I've recently been playing with, and when I'm working with a couple of dentists here, is this new protocol where I call the Lucitone twist. It's mesh mixing time. So briefly on the mesh mixer, if you're a dental lab owner and you're into digital dentistry, not using mesh mixer, it's not a good idea. So mesh mixer is a free tool from Autodesk. You can download it for free, and it really helps you manipulate STL files in ways that you didn't think you could. It's the reason why we use it a lot is because some of the software solutions from Exocad and 3Shape are a bit limited in scope of what they could do with digital files. And so we try to utilize Mesh Mixer to its full to do cutbacks, merge files more accurately, to do cleanups of really corrupted scan data or data that has a lot of artifacts on it. We can merge things, we can extrude things, we can copy things, we can, merge your setup with your tissue, we can open screw channels in certain cases. I mean, it's really, really handy. And it's in this case, what we've done is we've taken that full arch design that you've seen at the beginning, and we've kind of cut everything back in Mesh Mixer. And then we carried over that design. And what we did was we just copied basically our previous design of full contour, and we created three quadrants. Now those quadrants can be made in PMMA, zirconia, whatever you want. So then what we do is we take that cut back and we printed that out of the Lucitone material. So after that, we take those PMMA restorations and we put it on top of the Lucitone. And you can see we created sort of a different kind of hybrid that's very lightweight. It's very economical to make. You don't have to mill anything. It just gets 3D printed. And all the detail is there that you put in there because you're not limited by the size of your milling burr. And then allows the patient to have this really lightweight restoration. So this is, we have a couple of patients that we work with that we're kind of trying this new protocol out, and no one's really been doing this a lot, at least that I'm aware of. So this has been a really interesting development. And so the way that works out is with desk components here, you can really see how this Lucitone restoration, it's sort of, to me, is like a game changer, because I can have a lightweight design, lightweight restoration, same design that I used as before, so I don't have to change that in any way. I can utilize my desk components, my angulated screw channel. I don't have to do any pink gingival staining, and it's very light and economical to make. So overall, so far that we've seen, it's been a success, and we're going to try to do even more research to see how this can really become a thing for us and a solution for some of the labs that are faced with making a choice to go with a more affordable restoration. As a summary for Lucitone, it's a very light material. It's a very durable material. We try to run it over and break it and do a lot of things to it. It's not happening, so we kind of gave up on that. It's great because it can be relined, unlike a lot of other materials. However, I will say there will be some interesting developments at LMT this year. There will be some really new high impact resistant denture base and denture teeth materials. I can't share more, but be on the lookout because the industry is about to get a big shakeup in that space. And we're going to ask us as lab people, we're going to get even more options, which is going to be great. So be on the lookout for that. So for Lucitone, it's also color stable and it has BAM. That's what they call it. It's a body activated material that actually gets harder at about, I think, 37 degrees. When it reaches that body temperature, it actually increases in strength and that flexural modulus. So it's an interesting material. It's a good material. The downside con is it has to be printed on a carbon printer for now. So not every lab can afford it, but for example, you can outsource with Aurora and we'll print it for you. We have a bunch of carbons here. And then the resin is a bit expensive, but it does go a long way. And personally, digital dentures are still in infancy, and we still need more long-term research to see how they behave long-term. But I think we're on a really good track when it comes to digital dentures. And here, to briefly mention, we have the Trilor path. Now, the Trilor has been an interesting material. I call it a toned body material because it is lightweight, it is well-shaped, and it can take a lot of stress, and it has very low flex modulus. It's a very low flex rate. So it's pretty toned. Now, Trilor as I'm sure some of you know, is used for substructures. But a lot of people, like to experiment with it and use it for different things. Here, I took the same design that we saw before and that we used for that Lucitone, that cutback design. And then I went ahead and milled it out of Trilor. Now, Trilor tends to be a little bit heavy on the mill. So the burrs that mill it, you kind of need to reevaluate your milling strategy through your nesting software and kind of see, maybe you want to have dedicated burrs for it or do it on a more robust milling machine because it's a pretty strong material. And you can't just run it on a regular zirconia strategy. It's just either gonna undermill or it's gonna break your burrs. So once you acquire it and it's a good material to have, important to reevaluate that. So here, to give you an example, when we're talking about weights of things, that same case that you see here, it weighed 15 grams in the Lucitone twist that I showed you. The Trilor that you're gonna see is 20 grams and zirconia 71 grams. So as we take these paths, it's important for you to consider if doctor says, hey, I don't want to have a heavy restoration. What options can you give me? Well, doc, I can give you maybe Trilor layered with Gradia, or I can give you a Lucitone. Okay. But if there's no concern, it's like, but I want something really strong and aesthetic. You're like, well, I got transitions for you. So it's important to consider those weights of things. So what is a Trilor? It's a fiberglass reinforced composite. It has a flexural strength of 540 MPa and a tensile elongation of 2%, which is a measure of elasticity or deformation. This is why it became a really popular material where a lot of people started using it for bars and substructures because it has a really low flex rate. What I like about it is that it's white in color, so I don't have to worry about, opaquing it or doing anything like that. And so whichever restoration you put on top of it is kind of like shines. And you can individually, cement Emax over it or zirconia or PMMA or whatever. In this case, we're going to be doing that same PMMA frame that we did. So here's an example. I did this quickly to kind of show half of the arch, how it looks. This is a Gradia composite. We went ahead and layered some of that pink without those PMMA teeth that we went ahead and polished afterwards. And you can see it really comes to life. It's a really great material to work with, really stable, but it has to be, it's not for every application, just like any one of these materials that we mentioned. But the adhesion that I saw and the aesthetics, the kind of the light that shines through it, I thought was very good. Here is kind of a close-up, so you can kind of see that sort of like a meshy structure that the material has. Here on the left, you can see how those PMMAs look polished just straight on the material. And here you can see how Gradia and the PMMA come together. A lot of these restorations that I show can be used either for long-term provisionals, or if you replace this PMMA quadrant with like zirconia or something like that, they can be used as long-term restorations, but very lightweight material. So I enjoyed working with it. And here, obviously with desk components, because desk is the best. The pros and cons, it's an evolution to the metal bar. So that's great. We don't want to be doing any more, anodizing of the bars and then opaquing them and doing all these different things. When I worked at Nobel Biocare, that was a big part of what we did. We did it well, but it was very time consuming and it could be problematic if it's not done right. So it's a very light material, very aesthetic, light in color, does not require opaque, and it has a low flex rate, which is a stable substructure. The cons obviously requires layering in pink, which can be a bit time consuming, but so is everything in a dental lab, right? And like I said, it causes a good amount of wear on the milling unit. And here, I kind of wanted to give you just kind of like a quick summary where we kind of review everything that we've done. So for those restorations, so when we take that design in the middle, we can take it into so many different directions. So in the upper left, you see that PMMA. Then you can see how our implant components kind of go throughout the entire process. They can be incorporated into any one of these restorations. So that's sort of like a stable, focused item, and then we can choose different materials that they interact with. So PMMA, great for verification, right? That Lucitone twist that we showed you, it's kind of a new thing, very lightweight material, can be realigned. It's a huge benefit for a lot of guys who are worried about tissue management and what happens with tissue over time. It can be 3D printed, so that's a big benefit. And then we have Trilor, very lightweight, very strong, very stable material. We like working with it. And we have the Zirlux transitions, which is in the lower right corner, which so far has been a big game changer for our lab. Like I said in the beginning, we've got so many requests for that material in particular. And that's about it. I wanted to also at the end mention that I want to thank to all the patients, like we all should, who challenge us and allow us to change their lives every day. And they do challenge us, that's for sure. This patient was particularly happy with what they received, especially after they lost all of their teeth. And so, and for you out there who are in a dental lab space, you know, I really hope that this allowed you to learn something new. For those of you who know a lot, hopefully this was a refresher. And my point of all this was to really give you options and to equip you with knowledge so that when you make a decision how to take these cases to completion, you really know what your choices are and what the pros and cons are for each one of these systems. And that will be it. So this would be a good question if you have any. This would be a good time if you have any questions, so we can go ahead and answer some of those as well.
Thank you so much, Milos. Really an informative and engaging overview of digital workflows and what we're offering our customers. Your tips and tricks were really great as well. At this time, we do not have any questions in the Q&A panel. If you do have any questions, or you can think of any after our program today, please don't hesitate to reach out to a Zahn representative and we'll get you the answers that you need. We'll just give it another minute and see if anybody wants to engage in the question and answer section here.
Yeah, and also for your scientific credits, they're going to be posted in the chat so you can get your code for your CE credits as well.
Correct. We have a question from Dan. What are you using for the pink?
For the pink, we're using IPS ceram, but we also use creation porcelain as well. But we're constantly trying out new materials. What we found is choosing one particular powder doesn't really work. So what our ceramists end up doing is they end up mixing 2 or 3 different powders to get that effect, especially if you want to get some of those features and shadowing around the UGA and all the contouring that's around the gingival area. So yeah, but there's really, if I was to make a decision, I wouldn't go for a particular system to say this system is the best. As long as it's layered ceramic, that's what I really care about, because that's the feedback we've been getting. Our customers saying, I want layered ceramic for pink. They don't really care which ones we use. So that's been interesting. We tried to paint on ceramics, but just the detail and the light translucency and the light reflection we're getting from it is not quite there now, might be there soon, but we're definitely working on it. We're working off of a lot of feedback of what the lab owners are telling us. Do we have another one?
Perfect. Thank you so much, Milos. No, there is not another question. It was regarding NBC credit. I responded to that one already. I would like to thank you all for joining us, and thank you again, Milos, for the wonderful presentation.
Of course. Hold on.
Everyone have a great day.